Now, it is my inordinate pleasure to announce two of my wonderful colleagues, Joe Cassady and Rick Zucker. Another year gone by. What has been done? The Humans to Mars report just published gives you the answer to that question. My Explore Mars colleagues, Joe Cassady, the Executive Vice President of Explore Mars, and Rick Zucker, Director of Explore Mars, together are going to give us the executive summary of where we stand with our plans of getting humans on Mars. Joe Cassady is the proverbial rocket man with deep knowledge of rocket engines of various designs and mission architecture. Rick Zucker is the proverbial policy man and lawyer with deep knowledge of how Congress works. Joe and Rick, you have the floor.
Okay, could I have the first slide, please? So we're going to give you a quick run-through of the report that you all have in your folders, and I would urge you to read that at your leisure, and I think it's another outstanding report. Go to the next slide. These are the topics that you'll see in there covered. We've kind of taken this approach year over year, and the idea is as we are making progress on the plans that Artemis referred to, we like to take note of that each year and collect it into that report. And as Chris mentioned, we then take that up on the Hill and to other stakeholders out there across the nation and around the world to show them that, in fact, there is progress being made. So without going through these in detail, I'm going to cover the next section, next slide. So what did happen in 2018 in terms of Mars science and reconnaissance missions? And one of the things that I think Explore Mars has done an excellent job of is bringing together the science community and the human exploration community. And we look at the robotic missions that are out there now as precursors for our eventual human exploration of Mars. One of those exciting missions this past year was NASA's InSight mission, which obviously had a very successful landing and the beginning of its science campaign. And I'm just going to highlight for a moment here on this chart the very exciting news. As you see there in the pictures, the seismometer being deployed onto the surface and covered up with its little dome. The first Mars dome is actually in place on the surface of Mars now, covering the seismometer. But on Sol 128 on April 6th, there was a Mars quake sensed by this seismometer. It was a very small quake, but it was the largest of about 4 events that have been recorded to date. There were others on Sol 105, Sol 132, and Sol 133. So we're starting to see data come back already. And at the same time, the MOLE, the hammer drill, which is designed to penetrate 3 to 5 meters below the surface, is working its way toward that accomplishment. And it will be doing sensing of the internal temperature of Mars, learning a lot more about the history, as Matt said earlier, as well as what makes Mars behave the way it does. So next slide. A sad moment was also had in 2018. We lost opportunity. But again, this is a precursor mission. This thing, first of all, wow, supposed to last 90 days, right? Back 10 years ago. So it lasted almost 10 years, well outlasted all expectations, exceeded all expectations, took beautiful images like the one you see here of Endeavour Crater. But the science return from Opportunity is so tremendous that probably people will still be getting PhDs from that data when we are actually walking on Mars in the 2030s, I would bet. But the key thing that I think there from a precursor standpoint is we lost Opportunity to a dust storm. And that's a lesson learned that we have to pay attention to for future exploration of all types, including humans. So we're already learning these lessons from these missions. And we know on Mars that these planet-wide dust storms are things that we are going to have to prepare for and design for. So next slide. The other very exciting news coming back and continuing to come back is this intriguing presence of water near the surface of Mars. What we see here is a large ice scarp that's exposed at about 56.5 degrees south latitude with a pure water ice face of about 100 meters tall. In addition to that, from orbit, ESA was able to detect what looks like a liquid water lake beneath the South Pole, near the South Pole of Mars. So continuing evidence that there's water near the surface, areas that are resource rich that we can use as targets for our future human exploration that will provide us with some of the necessary things to help humans survive and prosper on Mars. Next slide, please. And finally, in 2020, we're looking forward to a very exciting international year of science missions. Of course, Mars 2020 will launch in July. The ExoMars mission with the rover Franklin and a surface platform also planned for launch in 2020. China has announced plans to launch a combined rover and orbiter mission, or lander and orbiter mission. And also, very intriguingly, the UAE has plans to launch their HOPE mission to mark the 50th anniversary of their independence in 2020. Beyond 2020, the future is a little more cloudy, but we are seeing very encouraging signs with the planning beginning for an international sample return mission for Mars. And this is something that all of us interested in Mars have been very excited about for years and wanting to see some progress on. And I think we're now starting to see the nascent beginnings of that mission coming together. Next slide, please. In terms of the architectures and systems for human exploration of Mars, SLS and Orion still form the backbone of NASA's human exploration plans. There was a little bit of a consternation this year about the schedules, and there were some alternatives looked at in the end. When those alternatives were studied, it was found that we're better off to stay on the course we're on, continue with doing the tests that need to be done to get SLS ready, and hopefully with a redoubling of effort, we can achieve that milestone in late 2020 or early 21. So we're still planning for those first missions with the system, the entire system, to take place and go back out around the moon in that time frame, followed up by a mission with a crew. And as we're going to hear soon, there's a new exciting acceleration of some of those crew plans for the moon. At the same time, next slide, many of the contractors supporting NASA have been continuing to look at architectures. My company, Aerojet Rocketdyne, has been studying the utility of the gateway near the moon for aggregation of bigger systems that could go on out to Mars, as well as check out of some of the operational aspects of that. When we start to think about putting together spacecraft in deep space, what are the things that we're going to have to learn how to do? Very similar to how we've been working on the ISS for the last 20 plus years. On the next slide, Lockheed Martin continues their looking at their Mars Base Camp architecture, which is an interesting study of an orbital platform at Mars that could support sorties to the surface with a multi-purpose lander vehicle. And what they've also been looking at is the utility of water, which, as we were discussing earlier, is rather abundant, both now on the south polar region of the moon, we think, as well as on Mars. And that can be used as a resource that can provide us with hydrogen and oxygen as the fuel for these lander vehicles. And so we actually can look at a water economy. The next slide shows several other architecture studies that have been going on in the past year. Boeing has done a very interesting paper on comparing their lunar architecture to both the Apollo architecture as well as the architecture during the Constellation program. And that is in the report. as well as studies by Sierra Nevada on an early gateway concept that could allow human exploration of the moon on a much more rapid scale, and also provide you with the aggregation facilities, as I was referring to in our Aerojet Rocketdyne studies. And then, of course, SpaceX continues with their development of the Starship, and they've actually been doing some testing of the Raptor engines, as well as building a prototype down in Texas. So many exciting things are going on in the architectures and systems world. Next slide. We had a very exciting meeting back in August. We've now had 6 of these meetings. We called them Affording Mars to begin with. We now call them Achieving Mars because we think we licked the affordability part. And of course, there's also a sustainability aspect. We want all of the things that we do, we don't want them to be something that are one-offs or in the mold of Apollo, where it was a flags and footprints approach. We want to look at how do we do this and then make it so that we can continue to go and do bigger and bigger things on both the moon and Mars. So at this particular workshop, we brought together lunar advocates and Mars advocates for 2.5 days and talked about how we could do things on the moon that will feed forward and help us do things at Mars. There were key findings in the areas listed here: space transportation and propulsion systems, surface systems, technologies and operations, and we made some recommendations for future trades that could be done, for instance, by the national academies. I'm not going to talk about that too much in detail now. There's a session this afternoon at 3:20 that'll go into that, so I encourage you to attend that session. However, I will put a scoop out for those of you who might be from the media. It turns out that the moon people and the Mars people get along. So, big news. Next slide, please. And the final area that I'll talk about before turning it over to Rick is human health and performance. These pictures are just great. I just love seeing all this, and I hope most of you are aware of all the really good work that's going on all the time above our heads out on the ISS. And these are just some examples, both focusing on things like astronaut health for long-duration missions, with things like the eyes, how to adapt to microgravity, how does our body adapt to microgravity, countermeasures for that, things like training for medical situations. When we go on years-long missions to Mars, we're going to need to be able to deal with medical emergencies, and things like growing fresh food. So all of these things are going on right now on the ISS, and out of our assessment of this, I'll go to the next slide. I think there's several key areas that we feel could be built upon from the work that's now going on the ISS. And that would include doing more of these year-long missions with the diverse populations. And I know NASA has recently announced plans to have the current woman astronaut be a part of one of those. We also like to see missions beyond LEO, and that's where the Gateway comes in, to address issues associated with more long-distance space flight. Obviously, it's important to have stable, adequate funding for the human health aspects for these deep space initiatives. And we'd like to see, and this one really came up recently, I think some of you were aware of the spacewalk issue. We need to look at design and integration for the human system that allows for the wider ergonomic and physiological diversity of crew, gender, and body types, and that gets into things like suits. And then finally, the really interesting one, and I think there are also some plans to do this, we'd like to see a full Mars simulation where a year-long stay on the ISS is followed up by the crew returning to Earth and going directly to a Mars analog on Earth and performing some of the functions that they would perform when they have landed on Mars, so that it gives you sort of the full spectrum of the transit as well as the first days back in the surface in a gravity well. So with that, I'm going to turn it over to Rick to talk about policy, I think.
Thank you, Joe. Next slide. So every year we spend a lot of time on this report going through many drafts. The policy section is probably the one where we spend the most time doing draft after draft after draft, and you'll see from this slide what I mean by this. Probably the most exciting thing that's happened in the past year is the announcement at the end of March by the Vice President that we're going to return to the moon in 2024 and then on to Mars in 2033. The second bullet point is about the President's proposed budget that came out earlier this year, and I put in the slide, it was $21.109 billion, but because last night we got the answer to that, but what is the number that's going to be proposed so that we can accomplish going to the moon in 2024? I'm sure we're all still analyzing that, and our next speaker, the administrator, will have a lot to say about that. I wanted also to focus on the number of congressional hearings that we've had on space in the past year. And one of the pictures here on the top is of one of those hearings, our very own Chris Carberry in one of those hearings. That was a hearing that occurred on July 25th, 2018 before the Senate's Space, Science, and Competitiveness Subcommittee entitled Destination Mars, Putting American Boots on the Surface of Mars. And we have this picture of a very pensive Chris Carberry staring off into space, and I say that he's actually looking at Mars in that picture. We're actually very proud of Chris. I also want to point out that at an April 2nd, 2019 hearing, NASA Administrator Jim Bridenstine testified, and that was before the House Science, Space, and Technology Committee that was reviewing the NASA's proposed fiscal 2020 budget request. He emphasized that landing humans on the moon in 2024 will enable sending humans to Mars in 2033. The next bullet point is about legislative outreach. In the past year and in many years previous, many grassroots visits to Congress have occurred. I helped run one of those visits. Excuse me. ExploreMars leads a group of nonprofit space advocacy organizations under the banner of the Space Exploration Alliance. And we go to Congress, anybody can come, and we get people from all over the country, and that's really important to let Congress know what the general public thinks. And we have over 100 meetings over 2 days. We do that at the end of February. There are other groups that come to Congress in February and March, and I urge everybody to try to participate in something like that because we're not lobbyists, and the congressional members and their staff want to hear from the general public. The next bullet is exploration policy finding. And this is something that came out of our AM6 workshop. As lunar activities are developed, such plans should be constructed in a manner that should feed forward to and advance the goal of human missions to Mars in the 2030s. That brings the lunar community together, the Mars community together. It makes it affordable, it makes it sustainable, and that was a very good finding of our AM6 workshop. In international policy, I'll go very quickly through that because Joe already mentioned. We have the ExoMars rover in 2020. There was a second International Mars Sample Return Conference held in Bremen, Germany in late April 2018. The United Arab Emirates Hope Mars orbiter is scheduled to arrive in 2021. The Indian Space Research Organization is planning a follow-up mission to its successful Mars orbiter mission in 2016. Japan's Martian moons exploration missions is designed to clarify the origin of the Martian moons, and that's scheduled to launch in the early 2020s. And China also plans to send an orbiter, lander, and rover to Mars in 2020. And Australia, in July of 2018, officially launched the Australian Space Agency. Next slide, please. Public perception. And this goes back to what I said about the importance of grassroots visits to Congress. The public gets very excited about space. In 2018, there were two particular events that excited the public and generated a lot of press coverage. the discovery of liquid water on Mars. In July 2018, ESA announced the discovery of what is believed to be a liquid lake under the surface of the Martian South Pole. The landing of InSight in November of 2018 generated a tremendous amount of public interest. This slide highlights some of the infatuation by the entertainment industry in Mars. The National Geographic series Mars, which is part drama and part documentary. Life on Mars is a film version of a short story by Cecil Castellucci called We Have Always Lived on Mars. Will tell the story of a woman who is a descendant of colonists who were abandoned by Earth years earlier, who finds one day that she can breathe the Martian atmosphere. And the first Hulu television series, which explored the challenges of taking the first steps towards colonizing Mars. Next slide, please. Public polling. There have been several polls taken in recent years, including one last year and one that was commissioned by Explore Mars in 2013, which I'll go over briefly. In 2018, Insider, which is a sister publication of Business Insider, conducted a poll of Americans to assess their opinions about the priorities of the U.S. space program and their understanding of the NASA budget. That poll found that Americans estimate that the NASA budget is 6.4% of the federal budget and would prefer it to be 7.5%, whereas we all know the actual number is less than 1/2% and was 4.5% during Apollo. The poll also revealed that over 60% of Americans did not know that NASA's budget was less than 1/2%. And the 2013 Mars Generation poll found that on average, Americans estimated the percentage at 2.5%. In that poll, the participants were told it's between 0 and 6%, and they came out with 2.5%, which is over 5% what it actually is, 5 times what it actually is. And the 2018 poll found that 85% said that the NASA budget should be increased. The 2013 poll found that 75% thought that the NASA budget should be doubled. There are other portions of this section that I urge you to read. There's an interesting section about Mars booze, which we should all be interested in. And is there one more slide? I hope that very, very soon we can point to a slide like that and say, home. Thank you.